let's talk more about slicing. Slicing is extremely important in Python and especially in NumPy, working with NumPy arrays. First thing I want to emphasize that slicing returns a view on the data. It doesn't create a copy. So it is, well, let me write it here. Slicing does not create a copy of the data. This is important. So if you will be using slices of your array and then changing your arrays, keep in mind that your slices will be changing as well. So let's start from simple, and this is exactly what you have in plain Python when you deal with lists. Let's start from one-dimensional arrays. I'll let x be a NumPy linspace 166. Obviously, it's going to give me an error now because I haven't imported my NumPy. Let me repeat the previous one. So I have this array from 1 to 6, one-dimensional, right? And then I can do, well, I can obviously take x, let's say third, right? It's going to be 4.0 because linspace gives you floats. Then if I want to take a slice of it, I do x. Let's say I'm taking a slice from the element with index 3, which is 4, or a fourth element, till the end, and it gives me this slice. So then I can do another slice of array, right? If I start from the column and finish with a certain index, it gives me a slice till this element, till the element with the index 3, which is number 4 in my case, right? Then I can do also more advanced slicing. So once again, just to remind you, this in these denotation, the first number is the starting position, the second is the stop position, and this is the step. So this will start at the element with an index 1, which is number 2, goes till the element with the index 4 with a step of 2. So it will give me just an array 2 and 4. If you can use the same notations, and if you don't specify the start stop, it will take the entire array, and you just specify the step. If the step is negative, it goes backwards. So this thing will give me my array backwards. Okay, so if we introduce a two-dimensional array, it will be a little bit harder, but not much harder. So let y be a NumPy linspace from 1 to 12 points, and I will do it here. So this will create me an one-dimensional array, but I'm gonna reshape it right away. Okay, I'm gonna reshape it with a shape 4×3. All right, so in one line we did this. We got these matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's perform some slicing operations on that. Well, let me print it first here as well. And let's get obviously if we want to get just a certain element in these matrix, we specify the index. Well, the first index will be the number of the row, right? And the second index will be the number of the column. And so if we do 3, 1, we'll get this 3, and this 1 should be 11, right? So this will be 11. Now let's take a slice of it. Well, also before taking a slice, just want to remind you, it's if you do something like that, Well, it will complain because we have, if you go back here, you see we have only 3 columns, so the index 3 won't be working. It will give us an error. All right, so let's take a slice. So if you do column for the first index, it means we're taking everything in a certain column, and then the second index will be index of a column. Let's say this one will take the complete column, the complete second column, the complete column with the index 1, right? 2, 5, 8, 11. All right. So then if you do something like that, 1 column, it will take a complete row with the index 1, so a complete second row, which is, you look here, and the second row would be 4, 5, 6. All right, that's trivial. Let's do something a little bit more advanced. So you do y, 1 column minus 1, and 1 column. So 1 to minus 1 means we're starting at this index and we're going till the element before the last element, right? And this index is for the rows. And then this is for columns, so we're starting at the column with the index 1, the second column, and goes all the way to the end. So we're getting here, so 5, 6, 8, 9, so this 5, 6, 8, 9, this part of the matrix. All right, let's do even more complicated. So if we do this for the rows, right, that means we go over all the rows with a step 2. So we're starting at the first row, and then the next will be the third row. Well, that's it. And then let's say we take all the columns. Okay, so this, if you want to actually display it, let's do z equals y. Okay, yeah, so that we can display it here. All right, so 1, 2, 3, 7, 8, 9. One more example. If I do y 2 column 2. So what this will do, it will take all the rows starting from the row with the index 2, right? The third row, so third and the fourth row. And here it will take the columns, well, before the index 2, so the first and the second column of our matrix. So I can again show you the matrix itself, the initial array. So we're taking this 7, 8, 10, 11, this part. All right, and let's give one more example. So if we do this slice, and here we take this one again, that means we're going with a step of 2, right? Here we're starting at the second column, second row, and here we're starting from the beginning and going again with a step 2, and that will give this slice for our array.